गोइंग लाइव बता रहा, या वी आर लाइव।
No, Lakshmi, I'm just gonna send you the
अभी के लिए माइक म्यूट कर
messages.
ओबीएस पे कर सकते हैं ताकि आवाज ना जाए उनको।
ये भी अपनी स्मॉल वीडियो भी चालू करो।
ये वाला ये वाला ना?
हाँ अब बोलो।
Hey everyone, let's start. We're gonna go over
नाम तो बताओ।
the paper one. I hope all of you are listening. Say hello to me so we can start. Okay. Right. So chemistry paper one tomorrow, and there are the topics as you can see on the board: atomic structure and bonding and properties, quantitative chemistry, chemical changes and energy changes. Okay. So I'm just going to go over the main parts of the spec which are important in 75 minutes. Okay, we'll go with basics, what can come up in the exam from the first topic. Okay, right, so let's start. In the first topic, the main important thing is about basic difference in the atomic structure. I'm going to write on the board, I like to write and explain things. The main thing that can come up in atomic structure is the definition or difference between compounds and mixtures. So tell me in the chat, what is a compound? The definition of a compound. Anybody knows? It's a very commonly asked simple definition for 2 marks. Okay, so compounds, in the chat, if anybody knows, can tell me the definition of compounds. Okay, so compounds are 2 or more elements. Very good.
Translate to karo.
Daisy, what translate?
Transition karo.
Can everyone see the screen?
Transition karo.
Yeah, so compound are, you are right, 2 or more elements chemically bonded. 2 or more elements chemically bonded. Now, the marking point, first marking point is to say 2 or more elements, and second marking point is to say chemically bonded. This is important. So please remember, this is your second marking point on a simple definition of compounds. Mixtures, however, tell me in the chat now, what is a mixture? How do you define a mixture? Don't forget to write the chemically bonded word for the second mark in compounds definition. So what's a mixture? Come on, Daisy, you answered me. Okay, so nobody knows, I think. So mixtures are, again, 2, yeah, correct, 2 or more elements not chemically bonded. Very good. 2 or more, it could be elements or compounds. Elements or compounds. This could be anything, okay, which are not chemically bonded. So I'm going to highlight the word not chemically bonded. Okay, fine. So this is one of the basic thing. Now we're going to talk about the next part, which could be another thing that you need to know, is about the definition of isotopes. Isotopes. So what are isotopes? Tell me in the chat. Now this is slightly higher level, like a difficult question. People are very confused with this definition. So let's talk about isotopes. Tell me in the chat, what's an isotope? Okay, same number of neutrons. Well done. Same number of neutrons. You forgot one thing. Before you say same number of neutrons, which is a marking point, sorry, I think we got mixed up here. So you said same neutrons. There we go. No, the other way around. Daisy, this is other way around. Okay, I'm going to correct this here. Now, look at the board, yeah? Yeah, the definition is isotopes, first marking point. I'm just going to tell you the first marking point first, and then we'll talk about the protons and neutrons number. First marking point is, these are atoms of same element. This is important to remember. Atoms of same element. This will give you 1 mark, right? With different number of, come on, tell me in the chat, different number of neutrons. You can't say, please, this is very important. Neutrons is the one that is different. You can see my screen, right? Yeah, different number of neutrons. This will be your second marking point. But different number of neutrons, very good. But What? But what is, so neutrons number is different, but what is same? Come on. Yeah, same, but same number of protons. Very important. Same number of protons. Third marking point. Okay. And because remember one more thing, protons number is always equals to the number of what? The two particles are always same. What is the second particle? Type in the chat. Come on. Protons number is always equals to, very good, electrons. Yeah, protons and electrons are always same in an atom. So if you have same number of protons, then your electrons will also be same. Okay, so you can write that in the definition, but it is not important to write. Most important thing for isotope definition is to say same element, neutrons number, and the number of protons. Okay, fine. So that makes sense. I hope this definition, there is a formula, a very important formula for everyone to remember. And this, they love to ask this calculation on isotopes, where you have relative abundance. So relative abundance. Anybody know how do you calculate the relative abundance of an isotope? Relative abundance maybe found for foundation. This you can skip this formula, but what we learned on the top, the definition of isotope, is important for foundation as well. Relative abundance, just check. I think for foundation it's not necessary, but for higher it is definitely. I can check for foundation later, but just look at this formula for now, for this evening. Relative abundance equals percentage of isotope 1. They will give you the percentage of it in the question. Isotope 1, you take the percentage of isotope 1 times it with the mass. Okay, and see, look at the board. You add that with percentage of isotope 2. Okay, percentage of isotope 2 times it by its mass. Please remember this, because, and then you divide that all by total abundance given. Total abundance. Abundance is not like, I know the word is complex, like what abundance means. It's just the how much it is. Okay, how much it is. How much percentage in a sample, for example. Now I'm going to give you an example here, so listen very carefully. Yeah, for example, if they give you chlorine and they give you the mass number. Now I'm going to talk about mass number in a minute. Big number is the mass number, which is 35. They will give you that. They can also write this as Cl35. Now people don't understand that, they don't know that this is the mass number they need to take in this formula. Okay, if they say Cl35 is equal to 75% in the question, and Cl37 is equal to 25%, and they ask you to work out the relative abundance. Okay, so what should we do? Come on, find out the answer. You must be having calculator or your phones around. Come on, find out the answer for this. Apply that formula. Come on, quickly. Very good. I don't know, it's Lochin. Yeah, well done. Very good, guys. You all are calculating, Daisy. Well done. So what we simply do is this. We just use the percentage of isotope 1, which is this one, 75. Okay, times it by the mass. Where is the mass? I'm going to circle the mass there. There we go. 35 plus percentage of isotope. Did I press 2 accidentally? I don't know what I'm talking about. I'm just going to check in a minute. Percentage of isotope 2, which is 25. Okay, and mass of isotope 2, which is 37. Yeah, it is AQA. 37. Just put 37 there. And total, what is the total abundance? This is total. Just add up these two numbers. That's your total abundance. And that's 100. Okay. And the answer is, well done. Some of you calculated, which is 35.5. Okay. That's your relative abundance. This is important, guys. Please hope. Okay, fine, Lochin. I will slow down. Yeah, it is in Edexcel, it is in Foundation. It is everything. Like this formula is everywhere. Like all the boards have it. Okay. So that's isotope. Now, can you just answer my fundamental questions, please? Okay. Fundamental questions. For example, mass number in the atomic number. So if I give you Cl, let's say, I'm gonna use, help me with this, guys, yeah? Carbon 6 and 12, carbon 6 and 13. Okay, tell me PEN, very basic thing that comes up. Protons, electrons, and neutrons number in each of them. Okay, these are 2 isotopes. Come on, quickly. This is simple. Come on, you can do it. Come on, everyone. How many protons do you have? How many protons do you have? What do we look at? Well done, Daisy. Well done, Nabel.
Latency.
Okay, so very good. For protons number, if you've forgotten, we look at the small number. Electrons is also the small number. They both are same. And neutron is the big number. Take away small number. And that will be 12. Take away 6, which is equals to 6. Please don't make a silly mistake by putting this 12 for the number of neutrons. No, you take away both the numbers. Well done. And for this, it will be 6, 6, and 13 minus 6, which is equals to, which is equals to 7 neutrons. Well done. And you can see different amount of neutrons, same amount of all other things. Okay, so that, which one is atomic number and which one is mass number? Quickly type in the chat. If I give you option 6 and 13 in the chat, come on. Come on, let's go. I am just asking you a simple question. What is the mass number out of 6 and which is the atomic number? Well done. We don't say, Omar, top is the atomic number. Yeah, just say this. Yeah, okay, fine. I agree that top is the, how will you define it? Okay, fine, Daisy, thank you. How will you define it? Come on. How will you define it? How will you define atomic number and the mass number? Nobody knows. I don't think anybody knows it. Nobody's answering. Mass, come on, you know it. Mass number is the, very good, Lochna. What? Say again.
Latency होती है, उनको बाद में समझ में आता है.
Ooh, okay, fine. No, we don't write that definition, Daisy. You'll have to say mass number is the, so this definition is important. Mass number, if you have been asked, just say mass number is the number of P plus number of N. P stands for protons and N stands for neutrons. You add these two numbers, that's your mass number. Okay? Atomic number, on the other hand, come on, everyone, please type in. You know this. Tomorrow you have your exam. What is atomic number? Quick. Atomic number equals Oh, Daisy, so you mean to say I should increase the speed of my chat? She's saying that my chat is slow. So should I slow down myself or what should I do? I don't know. I'm doing this for first time. So atomic number is the very good. I want somebody has written the answer. Number of protons. Well done, guys. Okay, what's the PEN? Another question. Come on, quick, basic question. PEN. What's the mass of proton? What's the mass of electron? Quick, mass of each particle. Tell me. What's the mass of each of them? Proton is 1 and negligible. Well done. Yes, of course. Well done. So proton is 1, electron is 1 over 1836 or 0, or you can say negligible. All is accepted. Negligible, you can say. Or a neutron is 1. Yeah, correct, mass. Now, if they ask you about charge, please do not make that mistake. Charge has to be, charge has to be, anybody knows? What's the charge on each of them? I will wait. Yes, very good. Proton +1, electron -1, and neutron is 0. Well done. Okay, fine. Let's move on. These are basics. Okay, so I think all of you are good with this. There are different scientists, who has discovered which subatomic particle. Let's talk about this briefly. Okay, talk to me about this. Who has discovered the electron? Which scientist is responsible for the discovery of electron? Come on. No. Starting with hold on. I will give you starting with J. Yeah, Nabil has got it. It's Nabil. I don't know, but I'm not good at pronouncing. Yeah, J. Thomson. Well done. He is J. Thomson. Electron. E stands for electron. Who discovered proton, guys? Who? Okay, hold on. I'm going to change my question. Wait. I'm going to change my question. Who has discovered... no. Tell me the name of the model that J. Thomson proposed. Starting with P. Come on, you know this. Very good. Derived. Yeah, this is plum pudding model. Yes. Protons was discovered by... Next question. Come on, let's go. Protons were discovered by... All of you are very quick at writing the answers. This is good to see. Come on, protons were discovered by... Starting with R. U. Come on. Rutherford. Well done, guys. Rutherford. What is the name of the model that he proposed? This is a very important model. They ask you high demand question from this part. Rutherford proposed which model? Actually that model is called it is called alpha radiation experiment. Well, he used alpha particles, remember? Okay, I'm going to write alpha scattering, alpha radiation experiment. Okay. Yeah, gold foil alpha particles. You can call it gold foil experiment. You can call it direct alpha radiation experiment, because remember, he used gold foil, definitely. He used gold foil and he bombarded alpha particles on the gold foil, alpha particles. Okay, that is what he did. The symbol is actually representing alpha. So he bombarded alpha particles on the gold foil. So you can call this as both of them. But what were the, tell me, what were the, this is important. I'm going to just quickly paste one thing here. See if this is making sense to all of you. Wait for a minute. Just give me 1 sec. Oh, sorry, I'm not very, I'm just doing this for first time, so I'm just a bit lost. But I'm just gonna put some important things that you need to remember about this part, which is here. Have a look. I'm going to keep my speed a little fast because we need to cover a lot in a little time. So, okay, here we go. These are some of the points that you must remember. Yeah, Lujin, it is in paper 2 as no, it's in paper 1. But you have alpha radiation experiment or gold foil experiment in physics as well in paper 1. So this is something you might not in chemistry paper 2 you don't have this, but in paper 1 of physics you do. So it says here, these points you need to remember. Deflects the at least it has opposite charge to positive nucleus. So only few of the alpha particles were deflected. Okay, because the opposite charge on the nucleus, and there is a very little mass. This is something you can just go over it. Neutrons move straight through. Okay, protons deflect the most as it has same charge as the nucleus and has the mass as well. Okay, give me 1 second. Sorry, I just got something here. Okay, yeah, sorry, I copied pasted something else. What I wanted to copy paste here, that's a different thing I pasted here. Sorry for that. I'm just gonna move it slightly down, and I'm gonna talk about alpha scattering of the particles. This is in everything like foundation or higher. All of the students need to do this. Okay, my question is, what were the findings of alpha radiation that can come up quite a lot? Now the wordings need need to be corrected. What were the most important thing about alpha scattering practical were, number one, that he concluded most of the mass, maybe you want to know this, most of the mass is concentrated where? Type in the chat. Where is the most of the mass concentrated? In the shells or in the shells? Where is it concentrated, the most of the mass? In the center. Very good. That's first finding he had, in the center of the atom. Okay, that is the first thing he had. Okay, please remember that. Okay, what is the second finding did he have? I think somebody already mentioned. Most of the mass is concentrated in the center of the atom. And the second one was, come on. Yeah, the rays were deflected back because of the center of the mass, correct? Most of the atom is empty space. Very good. Apart from the center, most of the atom, very good, most of the atom is empty. Atom is empty. Okay, meaning what? If it is empty means what? Most of the atom is empty means what? How did he conclude that most of the atom is empty? Because majority of alpha particles went straight through. So they went straight through like this. Have a look. They just went straight through like this. Like this. Particles went straight through. Okay. So he concluded most of the atom is empty as majority of the alpha particles went straight through. Okay. Passed through. Very good, Neville. That's correct. Okay. So that was Rutherford. Who discovered shells? Type in the chat again. Next question. Who discovered shells? Who discovered shells? Shells. Anybody? Yeah, we call him, yeah, Bohr. Correct. Bohr discovered the shells. Neutrons were discovered by, who discovered the third particle? Neutrons. Come on. Starting with C, H, A. Come on, come on, come on. Chadwick. Well done. Well done, guys. No, Bohr was shells. You know how, and this model is called nuclear model. What do we call it? Nuclear model. How many electrons? Write in the chat quickly. How many electrons? Write the electronic configuration. How do you? How many electrons in the first, second, and third shell? Electronic configuration. Come on. Type. How many in the first? 2. Very good, Daisy. 8. 8. Not 2. It's just 288. Maximum capacity is this. Look at the board. 2 in the first shell, 8 in the second, third, and fourth. All has the maximum capacity of 8. Okay? Okay, fine. So I hope this is making sense, guys, yeah? Okay, let's do one more, which is bonding, and let's talk about bonding and structure now, if that's okay. Because I think, oh no, one more thing I wanted to discuss about the reactivity. How many, what does group number tells you? You know, if you have periodic table, let's say this is your periodic table, what does group number tells you? The number at the top, like 1, 2, 3, 4, 5, 6, 7. Very good, Darid. Yes. What does group number tell you? Yeah. The outer shell electrons. Well done. Outer shell electrons. Electrons. Please remember that, yeah? Outer shell electrons. So, what do you call the group 1 element that you need to study? What do you call group 1 element? This one. What do you call them? No, alkali metals. Well done, guy. Alkali metals. What do you call group 7 elements? Group 7 elements are called, starting with H. Halogens. Well done. Halogens. Yay. They are called halogens. Okay, fine. Sodium. Na. Write the electronic configuration. If I tell you the number of electrons, total number of, the number, okay, there is a 23 on the top and let's say 11 at the bottom, or I can just switch it around. You can have both ways. 11 on the top, 23 at the bottom. Okay, which one will tell you the number of electrons? Well done, Derek. Very good. Write the electronic configuration, guys. EC, electronic configuration. Come on. 2, 8, 1. Well done. Of course. Okay. To get a full outer shell, what does this atom do? Sodium. What does it do? Gain 7 more or lose 1? Come on, type. Gain 7 more or lose 1? Loses 1. Well done. It will lose 1 electron and then it will be left with 2 and 8. Now comes ionic bonding. Very important, guys. Yeah. So you will get a question. Ionic bonding is very frequently asked in the exams. So let's talk about that. Will that be okay, guys? Let's talk about ionic bonding. Okay, let's see NaCl. Okay, all of you said, if they ask you, now element could be anything, you just have to see the group number. Sodium is in group 1, so 1 electron in the outer shell. Chlorine is in group 7, so 7 electron in the outer shell. Okay, now listen, yeah, if I show you sodium there with Na, right, and you need to only draw the outer shell, right, and draw 1 electron, because obviously it's in group 1, so 1 electron in the outer shell. Chlorine, on the other hand, draw out the outer shell again and draw how many electrons? Come on, type in the outer shell. It's group 7. Type in, come on, quickly. Come on. How many electrons in the outer shell? How? How 8? It's in group 7, guys. How will it be 8? Group 7 means group number tells you what? The number of electrons in the outer shell. Yes, Loshan. Okay, fine. I got you. Okay, so 7 electrons. Well done. So draw these 7 electrons like this. Now see, look at the board, guys. You must show the arrow from the cross to the dot. Number 1, don't make both the crosses. One has to be dot, one has to be cross. Okay, and then draw. After giving this electron to chlorine, sodium becomes like this. Na, shell is empty. You draw the square. If you do not draw the square, will you get the mark? Type in the chat. If for the ion, you do not draw the square, the bracket, sorry, will you get the mark? No, we won't. Yeah. After losing electron, what charge will sodium have? Come on, type in. What charge will sodium has? No, okay, yeah. It feels like if sodium is losing, meaning it should be -1, but no, it is +1, the other way. So how you can remember? Like this. See, listen carefully. Electrons are negative. And if you lose negativity, you become more positive. Feed this in your brain and you will not be confused. So you are losing electron, becoming more positive. So sodium lose electron and become 1 positive. He's losing negativity. Think about it like this. Okay, let's do the chlorine one now. Chlorine, okay. Draw out the outer shell. Again, do not forget 7 dots and how many cross? Come on. How many cross? Type in the chat. Come on. Yes. How many of you need cheat sheet? I can send you a cheat sheet where you can see what you need to know for tomorrow. Type in the chat so I will get someone to attach it for all of you. Okay, I will send you. I don't know how to do this, but we'll do this for you. I will send you the cheat sheet. Judy, for cathode ray experiment for the discovery of electrons, no, the cathode, it's not cathode ray. The experiment's name is, even I forget, alpha scattering experiment, or you call it, I will give you the exact name, nuclear, okay. Yeah, I will tell you. I will tell you what you asked in a minute. Okay, so there we go. Here you put the square like a bracket, and what charge will chlorine has? -1. Okay, this will give you 3 marks. Okay, so 1 mark you will get for drawing this, right? Second mark for this charge, second mark. Okay, second mark, and third mark for the brackets. So third mark for bracket, properly written, and the you draw empty for sodium and this for chlorine. That will be your third mark. And fourth mark is for saying oppositely charged ions. Write in the chat, repel or attract. Oppositely charged ions, oppositely charged ions, type in the chat, guys, attract or repel. Attract or repel, come on. Yes, attract. Well done. With what? With strong electrostatic force. Electrostatic force of attraction. This is your fourth marking point, guys. I don't know, what are you asking? I don't know what you're asking, Lochlin. Okay, see, listen to me, all of you. Please remember that for ionic bonding, these are the steps you must follow, because otherwise it's a very commonly asked question. Otherwise you will lose the marks. Okay, don't forget the brackets, don't forget the dots and crosses, don't forget the correct number of electrons in the outer shell. Yeah, now let's talk about the metallic bonding. Okay, let's do one covalent bonding first, quickly. Covalent. Tell me, covalent bonding happens between metals, only metals, or non-metals and metals both? What did I miss? Non-metals only. Very good. Non-metals only. Okay. Yeah. Yeah. And ionic bonding happens between a metal and a non-metal. Please remember, metal, and this is your non-metal, NM. Remember that. Okay, that's the difference. Covalent bonding, let's talk about, let's say, Cl. I think majority of you are okay with covalent bonding, isn't it? You can just put, how many electrons in chlorine outer shell? It's in group 7. Come on. How many electrons? Group 7. 7 electrons. Very good. So 6 in the outer, and then like this. Okay. Now that's your covalent bond. I'm going to talk about quickly metallic bonding so that you know what it is. Fast. Okay. Metallic bonding. Let's have a look. Metallic bonding. Does anybody know anything about it? Please type in the chat. Come on. Does anybody know anything about it? Please type in the chat. metallic bonding? Yeah, only metals is fine. What else? Very good, Judy. Yeah. Yeah, very good. So basically it happens between metals only. And if you have metal of sodium, for example, and what literally happens, 8 electrons, yeah. So 1 electron in the outer shell of sodium jumps out and becomes delocalized. That is something you need to remember. And this whole of the atom will become positive because obviously, see, listen carefully, yeah. Sodium loses 1 electron, or it just goes out of their outer shell automatically in the substance, and the electron is sitting in the outer part and becomes delocalized, right? Delocalized means it's not participating in the bonding, but it is just not in the metal atom. It's just out of the metal atom. Okay? So if electron is out from the atom, so negativity lost, it becomes positively charged automatically. Okay? So metallic bonding, now what's the charge on the electron, guys? Can you please type quickly? There are 9, the only few people are responding and some people are just listening. Please write the simple question I'm asking. What is the charge on the electron? Yes, Lochin. Only Lochin is responding to me. Jury, come on. What's the charge on the electron? -1. Yes. Yes. Now, all of these delocalized electrons, all are minus, right? And whole of this layer is plus. What will the positive and the negative do? Type in the chat. Repel or attract? Come on. Repel or attract? Come on. No, a positive and a negative opposite. Normally what happens, a male and a female opposites attract, right? Yeah. Similarly, yeah, positive and the negative charge, because the whole layer is positive.
What if you could create?
Whole bottom layer, which is electrons layer, is negative. The opposite charge attract. Okay. So what is metallic bonding quickly? It is, write it down if you want to, if you are writing in a book. It's a strong electrostatic force of attraction between what and what? Come on. Strong electrostatic force of attraction between. Anybody knows? Come on, this is now a bit high demand, so I'm just thinking people can answer my question. Very good, well done, Judy. It is the strong electrostatic force of attraction between. Very good. Yeah, the delocalized electrons, between delocalized electrons and metal ions. Okay, well done. So where are my delocalized electrons? I'm going to circle them. These are my delocalized electrons here, who have jumped out of the shells. Okay, and where are my metal ions? Here, which is the top layer. Okay, right. Fair enough. So that's your metallic bonding. How will be the melting and boiling point? Strong or weak? No, what I'm asking. Okay, I'm asking, how is the melting point of these metallic substances? Higher melting point? The sheet doesn't work. Very high. Very good, Judy. Yeah, they have very high melting point / boiling point. Very good. MP and BP means melting and boiling. Tell me, can they conduct electricity? Yes or no? Just write yes or no. Can they conduct electricity? Can they conduct electricity? Yes or no? Guys, yeah, okay, fine. They have a strong electrostatic force of attraction, so very high melting and boiling point. They can, yes, of course, conduct electricity. Conduct electricity. Force of attraction and intermolecular. Yeah, I will in a minute, Julie. Okay, so they can, yes, conduct electricity. Julie, tell me in the chat, which particle conducts electricity in metals? Is it ions or is it electrons? Is it ions or is it electrons? Very good. It is electrons that conduct electricity, which is delocalized. Well done. Okay, I'm going to go back to the top. Guys, pay attention. Look. I'm going to go back to the here in the ionic bonding part. Tell me, in ionic substances, again in the chat here, what thing conduct electricity? Is it electrons or is it ions? Is it electrons or is it ions? Come on. In ionic substances, what conducts electricity? Ion or electrons? Charged ions. Well done, guys. Do not get confused. Ions conduct electricity in the ionic substances. Well done. But in metallic substances, electrons will conduct electricity. Okay? Okay, fine. Right. Help me with this, yeah? If you have, I'm going to ask a question, yeah? Group 7 elements. What? Group 7. Okay? Right? Like fluorine, chlorine, bromine. Okay? How, I'm going to ask a question, so listen carefully. How is the boiling point of group 7 elements as you go down? As you go down in group 7, how is the boiling point? Does it increase or decrease? Yes, halogens. Does the BP stands for boiling point, increase or decrease as you go down? Yeah, the boiling point increases. It increases as you go down. The boiling point increase. Why? They increase. Reactivity. Okay, there are two things, boiling point and reactivity. Do not get confused. I'm talking about boiling point. No, it's not about shells. No. For boiling point, remember, it's about if I show you the size of the molecule, fluorine looks like this. It's a diatomic molecule. No. Hold on. I'm going to come to reactivity. Wait for a minute and listen to my explanation. You have got fluorine molecule, okay, in a container, okay? If you boil with a Bunsen burner, if you boil, this is my heat source. Listen carefully, yeah? And if I boil, what you break, this is my one molecule of fluorine molecule. This is my second molecule. In between them is the intermolecular force. Intermolecular force. What will happen if you heat them with this intermolecular force? What will happen? Will they stay or will they break? What will happen with the intermolecular force? Will they stay or will they break? They break. Well done. They break. So when the intermolecular force break, now see, the amount of boiling point depends upon the amount of intermolecular force. And amount of intermolecular force depend upon the size of the molecule. So chlorine is a big molecule. As you go down, the size of the molecule increases, guys. So does the intermolecular force increase, and so does the boiling point increase. See, this is my chlorine, Cl molecule. Yeah? Can you see the amount of intermolecular force you have in chlorine, which is this one, this much amount? I'm going to highlight it, the different color. See, this is the intermolecular force in this, and this much is the intermolecular force in this. So what's happening? What's happening? Oh, thank you. Well done, Luj. Yeah, very good. Very good, Judy. So as you go down, the size of the molecule increase, so does the intermolecular force increase. Therefore, you need more energy to break them, and that's why boiling point is increasing. Give me thumbs up. Okay, you understand. Well done. Okay, now if I go back to reactivity, see, there are two different things, reactivity and boiling points. What happens to the reactivity? Now you talk about the shell. Come on, tell me of group 7. Group 7, reactivity. As you go down, fluorine is of this size, 7 electrons. Judy, you will not get this. To explain, you will not get this. In group 1, explanation is not asked in the exam for melting and boiling point. Only for group 7 they ask. Yeah, I will tell you that later, but I think at this moment of time it's not of very much related or exam focus. Yeah, will that be okay? Just to remember this for the moment, Judy. Okay, what happens to reactivity of fluorine and chlorine? If I give you chlorine here, fluorine has 2 shells, chlorine has 3 shells. Tell me what happens to reactivity? They need to gain electron. There is an electron coming into the fluorine. There is an electron coming into the chlorine. Now listen carefully, yeah guys? Very carefully. Listen to this. There is a positive nucleus in the center. There is a positive nucleus in the center. What is the charge on incoming electron? Plus or minus? Type in the chat. What is the charge on incoming electron? This dot is representing electron, which is coming from a different atom. Minus. So the positive nucleus in the center and the minus electron, what will they do? Repel or attract? What will they do? Repel or attract? They will attract. Who will attract strongly? The one who has more shielding. Shielding means something in the middle, right? Which is obstructing the attraction. Like 3 shells will obstruct it more, or 2 shells will obstruct it more. No, CMAC, it says CMAC, I don't know the name, but they attract. Yeah, 3 shells, less attraction. So reactivity as you go down decreases. I'm gonna put this wordings, decreases. 1 marking point for saying the word decreases. The reactivity decrease. Why? Because size of the atom increase. This is 2nd marking point. Therefore, what happens next? Come on, tell me the next marking point. Come on guys, quickly. Type in the chat. Yeah, very good. Size of the atom increase, outer shell further, further. Therefore, less attraction from the nucleus to gain the electron. So less attraction from the nucleus, and therefore easy to gain the electron or difficulty in gaining the electron. Yeah. Yeah, not easy, difficult, because it's further, right? Electron cannot be gained that easily. Harder to gain the electron. Very good. Harder to gain the electron. Okay. Well done, guys. Well done. Okay. What else do we need to cover is group 4. You don't need to know, Lochin. Only group 1 and group 7. Okay, I'm going to talk about the moles concept, which is in every one of yours. No transition metals for you. No transition metals for you. Please ignore that part. Only transition metal is not there. Okay. Quantitative chemistry, moles. Okay. Tell me in the formula, how can you calculate moles if I give you... Okay, hold on. Do you remember the word MR or RFM? Who can answer this? Relative formula mass? Okay, fine. It is a relative formula mass. So, if I give you Na, yeah, correct. If I give you Na, which has 23 and 11, and if I give you Cl, which has 35.5 and 17, can you find out the RFM in the chat quickly? Find out the RFM. Let's see how many of you can do that. Find out the RFM for me. No, relative formula mass. You need to add them together, Suri. So, for NaCl, I said NaCl. I think I didn't write it on the board, so that's why I got confused. But you add the mass number together. Okay? Add the mass number together. Well done. Okay. Answer this now. Let's see how many of you can. What is the formula to calculate N, number of moles? Come on, guys. You know it. Formula to calculate number of moles. How much? What is the formula? Very good, Julie. Moles equals mass over mR. Well done. Okay. Okay. Help me with this. If I have, so if I give you, let's say, calculate the number of moles in 23 grams of NaCl. What do? You have your phone with you. Do the calculation quickly. Come on, everyone, and type in the chat. I want you to find out the number of moles in 23 grams of NaCl. Come on, guys. How one? Lochin, I think. If you see, what's the MR did you calculate for NaCl? it was what? 30. Okay, I have got no clue. So I'm just going to I'm going to write the formula first for this question on the top. N equals M over MR. This will give you 1 mark. Put the values in. What's the mass given? Mass is 23 gram. So I will put 23 over. MR is, how do you calculate the MR of NaCl? MR of NaCl means just add the mass number. 23, 23 plus 35.5 equals to 58. Is it 58.5? 23 plus. नहीं, I won't. Sorry, 58.5. So what's the answer? Are you doing the other way around? I think Judy, you did correctly. You can't just put MR on the top. Be very careful. You need to do 23, then divide, then 58.5. You can't do upside down. You can't just do this about, like, you can't put 58.5 and 23 on the top. This will be wrong. Okay, so I think Judy, you got the you did this correct way, which is 0.39. Yeah, so the answer is, so the answer is 23 over 58.5, which is equals to 0.39, I think. Yeah. Okay, moles. Fair enough. I'm just looking at your calculation. I'm just giving you questions from memory and working out the answer for that. But anyways, one more thing very important I wanted to discuss. Let's see how many of you can answer it, yeah? If you have this, conservation of mass. While I'm writing this, can you type in the definition for me? What is conservation of mass? What is it? Come on. What is conservation of mass? Nobody knows it? Conservation of mass. Come on, guys. You know it. Yeah. So, no atoms are lost or made during a chemical reaction. Mass of products is always equal to the mass of reactants. Well done. So, here we go. If I have Na plus Cl2, let's say, or I'm just going to use another thing. Yeah, so conservation of mass, what's the wordings I'm going to give you? Here we go. These are the wordings here. Yeah, I'm going to give me 1 second, yeah? And I will also tell you what exactly you are required to remember or understand for tomorrow's exam. Can you see on the board, guys? I'm going to paste it now in front of you. You can see. Can you see the definition here? Yeah. So what conservation of mass is, look at the board. No atoms, shall I make it slightly bigger? You can see it, right? If you're using your phone, you can't. Okay. No atoms are lost or made during a chemical reaction. Mass of the products is always equal to the mass of the reactants. That's what it says for conservation of mass. Okay. Now, here's a trap. The trap that you have for tomorrow's exam that you can have, like normally they ask or they check this. Combustion. Combustion. You might remember what combustion is. Somebody can type in the chat what combustion is quickly. What is combustion? Starting with B, U, R. Come on. Yeah, very good, Suri. Burning, obviously with oxygen. Yeah. Yeah. Judy, I will answer what you said in a minute. See, what is happening is that if you have Mg and if you burn Mg, you started with, let's say, 20 grams of Mg and you started combusting it. They will just trap you by saying that Mg, magnesium, is combusted. Okay? What you got after combustion was 35 gram when you reweighed it. So if the conservation of mass was true, listen carefully guys. If the conservation of mass was true, then why the mass increased when you burned magnesium? Type in the chat. Shall I repeat my question? Very good, Luchin. My question was, why the mass of magnesium, which was 20 gram, increased after burning? Yes, correct, Luchin. Why was this increase? And Luchin said, because oxygen has reacted. And that's the true answer, isn't it, guys? How much oxygen has been reacted? Remember, burning don't show you, or combustion in words. They will write, I'm combusting, or a student is combusting magnesium. You need to know that oxygen is connected from the atmosphere or chemically joined with it. Very good, Luchin. So how much oxygen has been joined? Combustion means reaction with oxygen, remember? How much oxygen has been joined? Yeah. Nobody knows apart from Luchin? Okay. So magnesium reacted with more oxygen, which you don't see, right? And from the atmosphere, you made magnesium oxide. This was 35 grams. So, and this was 20 grams. 20 grams. So this must be 15 grams. And why is this a trap? Because oxygen can't be seen, cannot be seen by you. But that does not mean it's not chemically joining. It is joining, right? So remember, combustion will increase the mass, and the increased mass is of oxygen. Okay, here is another trap. CaCO3 solid turns into CaO plus CO2. Type in the chat, everyone. We started with 30 grams. How much grams? 30. After the reaction, how much should be the total mass of these two? Type in the chat again. You started with 30 gram. How much should be the total mass of these two? Very good, Lochin. According to conservation of mass, should it change or should it be same after reaction? Come on. Yeah. Come on, everyone, type. After the reaction, should it be less than 30, more than 30, or just 30? Yeah, it should be 30 gram. Fair enough, Lochin. Now, but we saw, very good, Lochin. Yeah, but the mass seemed to be decreased. Why? Apart from Lochin, anybody else knows why the mass was decreased? If it should be 30, then why was it not 30 when you remeasure it after the reaction? Why? Why was it less than 30? Okay, I'm going to tell you the answer. What Lucien has said is that carbon dioxide is a gas. Remember? And you can see the state symbol at the bottom. Very good. This gas escape into the surrounding from the container, and therefore you can't measure it. You can't measure it. Okay? Okay, fine. So I hope this is making sense to all of you. I'm going to move on to another part, which is electrolysis. Shall we talk about electrolysis? Yes? Say in the chat, do you want to talk about electrolysis? Or no? Okay, let's talk about electrolysis. Electrolysis. Okay? Okay, fine. So in electrolysis, tell me in the chat again, everyone, yeah? What will you tell me is this? First of all, what electrolysis is? Electrolysis is just, anyone, Lucien, if you could answer, what is electrolysis? How do you define it? Yep, it is splitting. How you can remember? Electro means electricity. No. Electricity. So basically what that means is, I'm just going to write here so that you can see the definition directly for electrolysis. Have a look. Have a look. Simply what electrolysis is, just the splitting up ionic compound using electricity. You need to know this definition, guys. Yeah, you're just splitting up ionic compound using electricity. Yeah. And what is the other thing that is important? Yeah, could you please type in the chat if you can, everyone? What's the full form for panic? And what does it do? Like, yeah, just tell me, what is the full form of panic? Just give me 1 second, guys. Yeah, give me 1 second.
और उनको वो बोल दो कि कम होते चले जा रहा है बच्चे, उनको अब क्या मेन इम्पोर्टेंट है वो बोल। ऊपर वाला स्मॉल वीडियो। Yeah, sorry. Yeah, what do you mean by it is AQA? AQA. Say again? Okay,
Right. So guys, I'm going to let you all in a minute go and do your own revision, but I want to tell all of you, please remember how to do this half equation, if possible, because they always ask you questions on half equation. And just know the definition of electrolysis, the half equation: positive is anode, negative is cathode, that oil rig oxidation is loss of electrons and reduction is gain of electrons. And also, please do look at the I've sent you, I think we will send you the cheat sheet where you have majority of information that you need to know. It has been sent to all of you anyways. Okay, and I hopefully will see you for physics paper 1, and I hope that this exam goes well for all of you. Yeah, everyone? Okay, bye. How do you disconnect it? Yeah. Bye everyone. Bye.